Okay. So here, just wait for a second. Let's get it. So after yesterday, in fact, we are starting about the various operators, and there we have seen till now this arithmetic operator, right? That is the most basic operator. Otherwise, there are several other operators like, say, Boolean operators. In the case of Boolean operators, there can be several Boolean operators. That means Boolean operators means that perform the operation bit by bit. Okay, and suppose and, or, XOR, okay, and binary Boolean not. Now, how do they perform? As an example, suppose let me take say 73 and 59. Now, if I perform the binary conversion, this 49 in hexadecimal, so this should be 01001001 in binary, and 59, this should be 48, so 11, that means it should be 0011 1011, right? So these are binary conversion of these two decimal numbers. Suppose in two variables I am storing these two numbers, okay, and if in another variable, if you want to store their uh, Boolean, and what it will be stored is that in that case C will get 100100000. So eventually it is going to get only 9. Okay, and if I suppose store int d is equal to a or b, d will get, as you can expect, 110111, right? And we have to evaluate this, though there may be several ones, but its evaluation is, so it is 127 minus 4, so this should be 123. So the value of d will be 123. And if I perform int e, suppose a XOR b, e in that case will be 1 and 1 0, 1 0 1 0, then 1, sorry, this will be 0 because 1 and 1 0, then 1 1 1 0. So 0 1 1 1 0 0 1 0. So this will be something like 2 to the power 7, 2 to the power 7, 2 to the power 6, plus 2 to the power 5, plus 2 to the power 4, 3 2 1 0. So 2. So 64 plus 32 plus 16 plus 2, whatever result comes out, 96 plus 18, so 140. So value of e will get us 140. Okay, okay. Let me just show them how they work. Is my Is this screen visible? File Explorer? This coding screen, is it visible to you?
No, sir.
That's not
No, sir.
visible because I mistakenly shared only that window. Let me stop the sharing and let me start the sharing of my whole system. Enter screen. Is it visible now?
No, sir.
Okay. So let me remove this.
Now visual,
Okay.
sir. Visual.
Yesterday's
And now
discussion. Yes. Okay. Thank you. Let me tell you. Yesterday I tested with this. The fact is, what it gives is a pure garbage value. When you are trying to, though in all other cases, when uh, you are representing using certain format specifier, you are printing using format specifier, the format specifier in fact converts the corresponding memory content in the corresponding data type and then shows that to you. But that's not what is happening when you're trying to print float as an integer. Okay, what it in fact generating is a pure garbage value, random values. So that's why all of you are getting separate results, and that's a quite strange behavior, but that's in fact is happening. Well, so what I was saying, let me perform these operations. I am going to write it within a single window. Say d percent d and percent d. I'm going to print them up. A and b, a or b, and a is or b. And if you compile this, you'll see 9, 123, and 140. The results that we have, that we are expecting. Yes, 923 and 140. Okay. Now, similarly, if you write, say, int d as not of a, suppose this is again binary not, and we have seen a as already 0 1 0 0 1 0 0 1. That's in binary. So if you do the not, what you will get is 1 0 1 1 0 1 1 0. Now, depending upon, as for example, here I have written int. So in fact, this will be expanded to 32 bits, and there will be 28 more ones in front of this. Not 24 more ones in front of this. There are already 8, and 24 more ones will be in front of it, making 32 bits. So, and if you convert it into a char, and in that case, D will contain only this 1011 0110. And whether you keep this D as char or unsigned char, the value differs, because as I discussed previously, computer, your operation will return you just the bits. It's up to the programmer how the program is going to represent that bit, either as a signed or as an unsigned. So if you take this as a signed value, what you're going to get is minus to the power 7, or in fact minus 0 1 0 0 1 0 0 1 plus 1. So in fact minus whatever is the value 73. This is giving you 73 plus 1, that means minus 74, right? Whereas in the case of signed, whereas if you take this as unsigned char, and you will get some different value for that. Now this will not be a signed bit anymore, as you know. So this will be 2 to the power 7 plus 2 to the power 5 plus 4 plus 2 square plus 2, and its overall, and whatever will come out as a result of its calculation. Okay, I am not calculating further this, but this is what you're going to get. So that, so if I put say char c equals not a and unsigned char d, suppose not a, and I'm going to print their integer value. Obviously, I'm not interested in their character representation, but what integer they are representing within memory. Sorry, I wrote the wrong symbol here. This is conditional not. That was a mistake. For Boolean not, this is the tilde symbol. So this will be tilde a, this will be tilde a. Okay. So as you can see, minus 74 in the case of char and 182 in the case of unsigned char. That means if you add these values up, you will get 182. So,
Sir,
bolo.
so can you please briefly repeat what these three signs do? I was a bit late,
Just,
sir.
okay, just let me elaborate. And does bitwise AND. That means suppose you are doing the AND of 73 and 59, you will do their bitwise expansion. Now you do the bitwise AND. As for example, if you do the bitwise AND of 73 and 59, you are going to get this bit pattern, which means 9. And as you can see that if you do the A and B, you are going to get 9. Okay. Similarly, A or B does bitwise OR, right? And if you do the bitwise OR, it's 1 and 1, 1, 1 and 0, 1, and so on, what you will get is 123. And this is what you're getting, 123. And this caret symbol does bitwise XOR. And if you do the bitwise XOR of them, you'll get 114. This is a bit pattern. You'll get 114 from them. And this tilde symbol, that means the symbol on your tab keyboard, tab key, you'll get bitwise NOT or Boolean NOT. Is it clear? And in the case of
Yes, sir. Please, sir. Yes, sir. In the character case, that signed and unsigned, why that negative 74 came?
Okay. See, A was this, right? Suppose A is 0, 1, 0, 0, 1, 0, 0, 1. I was storing it as integer, so there were 24 more zeros in front of this, right? Now
Right.
what you're doing here is Boolean NOT. So D will become 1, 1, 1, 1. There will be 24 ones, 1. Then from there, this bit pattern starts. So 1, 0, 1, 1, 0, 1, 1, 0. Okay, for this one. Now, as soon as I'm doing it, I am trying to assigning it to char. The first 24 bits will be truncated. Only the last 8 bits will remain. So 1, 0, 1, 1, 0, 1, 1, 0. This will remain, right? Is it clear till
Yes.
now?
Yes, sir. Yes, sir.
Now, this is the bit pattern. Depending upon whether you read represent it as signed or unsigned, you will get different value because the first bit is signed bit and first bit is 1 in this case, isn't it?
Okay.
So if you represent it as simple signed char, when you are writing nothing in front of this, it is by default signed. So when you're representing it as a signed char, so eventually this will become negative because the first bit is 1. Obtain its corresponding 2's complement to know what value it represents, and you're getting minus 74. And if you do the unsigned one, that was when I discussed about unsigned, right?
Yes,
I think
sir.
I discussed about unsigned previously, isn't
Yes, sir.
it?
Yes, yes.
So when when you are using unsigned, the first bit is not signed bit anymore, it's a value bit, right? And so all of the bits will be recorded as values, and what you're getting is, I have not added it up, it is 182. If you add it up, you will get 182. So that's why in the case of unsigned carry, you obtained 182 because all the bits are value bits now. See, this is even this bit is not being considered as signed bit. This is the 2 to the power 7 part, this 2 to the power 5 part, this 2 to the power 4, this 2 square, and this 2 to the power 1. That's what unsigned keyword does. Is the concept of unsigned clear?
Clear, sir. Clear.
Okay. Okay. So now, after the arithmetic and Boolean operators, let me discuss some special operators. In fact, one of them is shifting operators. Uh, this one is left shift. Okay. Left shift means you are going to shift the number, all the bits on the left by a single bit. In fact, you can pass, suppose if you write A, this, that means left shift A by k bits. Now, what is the consequence of this? Let me consider any number. Say, let me take this 73 from here. Okay, 0 1 0 0 1 0 0 1. This is 73. Now, if you do the left shift of 73 by a single bit, what will happen is that all the bits will be shifted left by 1 bit. So this 1 will come here, this 0 will come here, this 0 will come here. That means consider like now when you left shift, this 1 will come here, this 0 will come here, this 0 will come here. That means everyone will be shifted left by 1 bit, whereas this 0 will go out. So if you left shift, you will get 1 0 0 1 0 0 1. Now when it will be left shifted here, this cell will be empty and 0 will come from here. So result of left shifting 73 by 1 bit will be this 1 0 0 1 0 0 1 0. Now there is something to discuss here. The fact is, again,
Sir, before
हाँ
that,
बोलो.
so the last place or the last places which are left because of shift, they will be filled with zero or the numbers which we have taken from the first places.
That is circular shift. That is circular shift. If you take the number, that means it rounds here this one. That is called circular shift. What I am doing here, in fact, there are three types of shift in architecture. One is this simple shift. That means the first bit simply goes out, and the last bit simply comes in. That's logical shift. Another is the arithmetic shift does not come in the case of left shift, that comes in the case of right shift. I'll come to that point. And circular shift is when the first bit goes to here. I'll show that, don't worry. So now see, 73, when it is left shifted by one bit, this is what you'll get. And what value you will get out of this again depends upon the data type you are using. If you are using, suppose it is int a is equal to 73, and then you are storing int b is equal to 73 left shifted by one bit, then there is no problem, because there were 24 zeros in front of this, sorry, 25 zeros in front of this. There will be now 24 zeros in front of this. Okay, and what you'll get, you do not need to evaluate this. Left shifting by one bit always multiplies by 2, so you'll get 146. This is very important point, remember. Left shifting by one bit multiplies with 2. But what if you store it into a character? As you can see, in that case, this first bit is 1, and what you'll get is again a negative number, depending upon whether you are taking a signed char or unsigned char. In the case of unsigned char, you will get 146 again, because this bit will be considered as the value bit in that case. Let me show that. Suppose it's character C, and I'm going to shift it left by single bit, and unsigned char shifted by, again, that A is also being shifted by 1 bit. Execute this, you can see that the first one has become minus 110. In fact, if you take this bit pattern as signed, this gives you minus 110, and as unsigned, this will give you, as I said, because the value bit is not being wasted, the value is left shifted to the first cell, and you'll get 146. That's what you're getting here, minus 110 and 146. Okay, now to the question, whether the first bit goes to here, because in this case you may think, well, 0 came out of the first bit, so 0 should go there, right? Now let me shift this, left shift this by another bit. So whatever you received here, say character B 73 left shifted by 1, and this is 100100010. Let me shift it by another bit. So 73 left shifted by 2. 2 means do one shift 2 times. So this will be left shifted, but this time this will be 001001000, not 1. Okay. If there would be 1, then it would be a circular shift, but there will be 0. Let me show this. So let me use another character E, that is going to left shift C by 1 bit or A by 2 bit, anything else, both of them will be same. check as well. And as you can see, it is giving you 36. That means an even number. In fact, if you evaluate this 0, 1, that means 4 plus 0, 1, 2, 3, 4, 5. So 32, 36. Left shifting 73 by 2 bits as character is giving you 36. Is it clear? Is the concept clear to all of you?
Yes, sir, clear.
If the first bit would go there, in this case, this 1 would come at the end, but 0 is coming again. So it is logical shifting. Now, what int C73 left shifted 2 would give? In that case, it would not give 36. Rather, it would give 146 into 2, because it is now int. You have all the bits left. In fact, you get a lesser value. You get a lesser value here, because this first one got removed. Okay, but in the case of integer, the first one will not be removed, right? In the case of 73, as for example, say this is 0, 1, 0, 0, 1, 0, 0, 1, and there are 24 more zeros in front of this. Now, if you left shift this by 2, this will come here. Everything will be left shifted by 2 bits. So 1, 0, 0, 1, 0, 0, 1, 0, 0. Right. So, and this no value is being removed in the case of int. And what you'll get is 146 into 2. In short, 73 into 2 square. So one thing you can understand, that A left shifted by K, considering that after left shifting all the bits are intact, that means if even after the left shifting the value is within the bound, this will give you A into 2 to the power K. Okay. If you take this into an int and left shift by 2, I'm this time I'm not doing left shifting C by 1, because C has already chopped off all the bits from the first. So I'm just taking this int directly and shifting left by 2. We'll get is 146 into 2, 292. So always keep the number of bits you are working with in mind. That's very important. That's why data types have appeared, because the bits, if some data cannot be held within a particular amount of bits, all the most significant bits will be chopped off. That means the first bits will be chopped off. Only the least significant, last 8 bits or 16 bits in the case of short, only them will remain. So you have to evaluate them accordingly. And after evaluating, if you see that let me write this as a rule so that you can keep it in mind. Always look for bits and size of the data type or size of the variable being kept or being used to hold. Okay, only last bits will remain. This is very important point. And another important point, among the last bits, among the remaining bits, If first bit is 1, again look for the data type. Look for the data type, whether it is unsigned or signed. And evaluate accordingly. These are very two important points you have to keep in mind when you will perform these bit operations. Is it clear? Is the concept clear to you all of it till now?
Yes, sir.
Okay.
Yes, sir.
Now after this, two arithmetic operators that we'll discuss. Increment, decrement. In fact, x is equal to x plus 1. Its shorthand is plus plus. Okay. And x is equal to x minus 1. Its shorthand is minus minus. Now how to write this? I'll show this with the increment operator only. All the discussions are same for decrement operator. Just minus will be done there. There are two types of increments as well as two types of decrements as well. Either post increment when you write as x plus plus, or pre increment when you write this as plus plus x. Now, as standalone instruction, they are equivalent. Remember this. As standalone instruction, they are equivalent. That means, suppose if I write int x is equal to say 12. If you do x plus plus, you will get 13. Other than that, if you do plus plus x, you will get 13 as well, because they are standalone instruction. But their behavior will be different when you use them in an expression. Okay, in expression, their behavior will be different. And how that will be different? In the case of post increment, first value will be used in expression, and then it will be incremented. It's several lag in the network access. And then it will be incremented. Whereas in the case of pre-increment, first it will be incremented, and then it will be used in expression. Let me show this with an example. Show it directly here. Suppose int a is 12 and b is 23. Now suppose I'm writing int c is equal to a plus b. What will happen here that a plus b, because it is post increment, because plus plus comes later, so a plus b will be done first, then a will be incremented. If you print the value of variable c, in fact let me print the value of a as well, there is no point in printing the value of b. You can see that 12 has become 13, so a has been incremented, but in the operation it is 12, it is still 12 plus 23. That's why we are getting 35, isn't it? Now let me comment it out, and if I now write int c is equal to plus a plus b, a will be incremented first, and that means it will become 13 first, and then will be added to b. So in that case, 13 plus 23, you can expect that the value will come as 36 rather than 35. So the value of c has appeared 36 because a got incremented to 13 before being added to b. Okay, so that's the difference between pre-increment and post-increment. And another thing, let me tell you, never use multiple increments or decrements of single variable in an expression. So you may be tempted to check what happens with a plus a or something like that, but the fact is its behavior is compiler dependent. How the compiler will generate the corresponding assembly code, it is dependent upon that. Okay, as for example, in this case, if you execute this, you are getting 26. Right? Just 1 second. Okay, sorry for the interruption. So what happened here is that it gave you 23, as you can see. It gave you 26. But why? Because first, in this case, what compiler did is first this plus plus a got into action. Okay. In fact, internally, let me tell you. When any operation happens, it creates a tree that's called parse tree. And this plus got what I have written here. First a plus plus and then plus plus a. Now, in normal expression, does not matter in whatever order you evaluate them, it doesn't matter. But it depends upon from compiler to compiler. If you write something like say simple a plus b, does it matter whether b is evaluated first or whether a is evaluated first? Right? But when, or even if you write simple a plus a, even in that case it would not matter, because during the operation the value of a is not being changed. But in this case, the order of operation matters. Okay. So if plus plus a gets evaluated first, plus plus a eventually means increment in memory first, and then sent to register, because eventually all the variables will go to registers, if you can remember from our discussion. Okay. And a plus plus means just the other way around. Now, if plus plus a gets changed, if plus plus a gets evaluated first, 12 will become first 13. Then it will be sent to the register. Right? So if this is the RAM and this is the a sitting here, a will first become 13 and then it will be sent to the corresponding register. Suppose it is sending to certain register, say RAX. Then a plus plus. Observe here, a plus plus will be evaluated later, as you can see from this machine. So in that case, this 13, a plus plus means what? First, it will be sent to a register. Suppose it is sent to another register, RBX. Now, this is for the plus plus a. Now, for the a plus plus, then it will be sent to the RBX, and then it will be incremented in memory, 13 to 14. And here we have 13. Right? 13 is first sent, then it is incremented in memory. And what you're seeing here, eventually the RAX and RBX are being added, and what you're seeing here as a result of 26. Right? That's why you're seeing 26 here. Whereas if we would do the other way around, say plus plus a, it's 7. So well, anyway, I'll have to check for the compiler code what it generated. Okay, because in my logic it would have 25, but somehow it is generating 27. But anyway, it varies from compiler to compiler. Never use in your future programming life ever a code like this. Such question will not be coming, will not appear in exam as well. Just never use multiple increments and decrements of single variable in a single expression. Okay, because the behavior will be Behavior will vary from compiler to compiler.
Sir,
Huh.
can you print A plus A plus plus?
A plus A plus plus. In that case, this 25. Again, one variable is incrementing while the other variable is being used. So it is not also quite safe. But what about if I use A plus 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 A? It's 26.
It's
So
26.
it's 26. So A is, so one thing observe here, for this plus plus A is first being incremented to 13. Right. Now the value of A is already 13. So these two 13 are being added and it is giving you 26. Is it clear? Whatever I said. Whereas if you do A plus plus, this A is being taken to the register, or this for A plus plus, maybe it may happen in this compiler on the machine that I am using, but you may get different results than me if you're using different compiler. At A plus plus, first 12 is being taken to the register, then it is being incremented to 13. The value of A is now 13, and 13 and 12 is giving you 25. Is it clear whatever I said?
Okay, so sir, you mean in your machine first A plus plus is counted, then A is added.
Yes, that's what I'm saying.
Okay, sir.
Otherwise, as I've said, it's not in fact machine, it is compiler. In fact, if you run it on some online compiler or somewhere else on Windows, you may even get different results. You can check it out. Okay, and you can let me know. Right. But uh, but always remember this, never use such type of expression. Okay. Now any of you have any query till now? Any query regarding all the operators that I've discussed? Now, what I'm going to discuss is, in fact, there are several other arithmetic operators. In fact, they are assignment operators. And this operator is available for all the arithmetic operations and Boolean operations. A, uh, suppose plus equals B. This simply means A is equal to A plus B. I hope you know this already. So I'll just mention it. So if the left hand side variable and the first variable on the right hand side are the same, in fact it means you are updating the variable. It is used to update a variable. So is it here and you are getting a new value of it, right? Similarly, A multiplied with B will give you A is equal to A into B. A divided by B, you can expect the same expression. A percent equals B, A modulo operator. So A will be A percent B. Okay. Or then A and equals B. and A XOR equals B will give you A equals A XOR B. I'm not showing options. You can easily check that out. Or let me show just one. A equals suppose 12 and B equals suppose 5, and suppose I'm going to do A multiply equals B. This is equivalent to writing A equals A into B. So new value of A will become 60. That's another percent here. So it took value from random memory, not random memory, the next byte which was not available. So is today's is the discussion that I made in this class is clear? In the next class, I'll discuss about the conditional operators, and today I'll not discuss much after that, because tomorrow from 2 p.m. up to unbounded time, I will take the class of both D and E together. I'll send a link to you, and there we'll discuss about that means after the conditional operator, what will go is directly to the if else, that means conditions, then loops tomorrow.
So what about 5 to 6 class?
5 to 6 क्लास में मैं conditional operators डिस्कस करूंगा. सारे के सारे
Today?
operators आज डिस्कस. हाँ, today 5 to 6. Yes,
Oh,
today's 5 to 6 class. Okay.
okay.
Tomorrow from 2 p.m. I'll take a class. I'll start taking a class. I do not know when it will finish. So be prepared. Okay.
Sir, notes. Yes sir, notes.
नोट्स में हाँ नोट्स में आज का पूरा नोट्स मैं कल करके मैं तुम लोगों को भेज दूंगा. इनफैक्ट ई को भी मैंने अभी तक नोट्स भेज नहीं पाया हूँ. मैं तुमको और ई सेक्शन को मैं नोट्स भेज दूंगा, क्योंकि यहाँ तक आकर नाउ डी एंड ई बोथ ऑफ द सेक्शंस आर द सेम पोजीशन. ओके, मैं तुम
सर
दोनों
आप
सेक्शन को
ऐसा
ही भेज
कीजिएगा,
दूंगा.
कल वाला कोर्स भी साथ में कर दीजिएगा, तो कल आपके हिसाब से ज्यादा कोर्स हो जाएगा ना, तो उस हिसाब से.
कल तो मैं बहुत दूर तक पढ़ाऊंगा.
हाँ तो सर वो सारा साथ में ऐड करके नोट्स दे दीजिएगा.
हाँ ठीक है. तो फिर कल का सारा नोट्स ऐड करके मैं दे दूंगा. ठीक है. आज 5 to 6 का क्लास ज्यादा लंबा नहीं होगा, मैक्सिमम 20 to 25 minutes, because maybe I would have started if else and so on today, but I'm deliberately not going to start because I'm going to show them along with E together tomorrow. Okay, so आज 5 to 6 का क्लास ज्यादा लंबा होगा नहीं. ठीक है.
Okay sir.
Okay, so we'll see you at 5 to 6 class.